Hello, and welcome back to Learning with Lee. In today's episode, we're going to finish up our discussion of strings and the different methods that you can use on strings. And technically, there's a few more things that we haven't covered in this series and won't cover in today's episode on strings. Some of which we'll be covering in the future when we get to iterators, some of which we'll cover in the future when we get to allocators, and some of which we're just going to ignore for now because it's easy enough to understand from all of the other things that we've covered with strings. And if you need to use them, you can easily find out about them. So they aren't as important as the stuff that we're going to be covering so far and covering today. So to begin with, we're going to discuss how to get a substring. And there's only a single method for getting a substring. It has two different versions to it because this is an optional argument over here. But basically it's like, okay, I want to start at this position here. So basically skip the first 10 characters and go to element 10. So you can see here we've got 5 for score, 4 for 4, and then the one for the space here. We skip over those 10 and we start at this space here, which corresponds to this space down here. And as you can see then, that is how just this single one works. When we put a second one in, it ends up grabbing this substring, in which it ends up going for 10 characters beyond that first one. So we start, in this case here, at index 10, and we end at index, technically I guess would be 19, but that's how we end up doing that substring. Important things to note about. Even though I do something like this, and this is a perfectly valid thing that you can actually do, is you can get a substring, and then you can modify that substring. Because what substring returns is it actually returns another string. So you can modify that, you can assign it to something else, and you can use it. However, it does not modify the original string. This is a brand new string. And you can see that down here in that we don't have a capital Z in this line here, even though we're assigning capital Z to where this U is. Or actually, sorry, more accurately where this R is. You can also then search. And the reason why I covered substrings first, basically all this finding logic is it ends up using substrings for a lot of the different stuff that you end up doing in here. So in case I want to end up searching for a substring in this case here, in which I want to search basically similar to what we did up here with this substring of 10 to 10, you basically give it, once again, 10 for where you want to start, 10 for where you want to end. And you can imagine how in some of the earlier stuff we were doing with replace, with some of the stuff for modifying strings, that a lot of this logic ends up using substrings underneath and hidden behind it in order to do a lot of it ends up using this function or more low-level versions of what this function actually does. So those all happen to be really side things that you can go back, look at, and go, oh yeah, this makes sense for how they're actually doing it behind the scenes. But for searching, if I give it this string here, and I want this substring here, and this is basically what this does, is if you give it some string, and there's a few different overloads on this. In general, there's 4 major overloads. There's this one here, this one here, this one down here, and then there happens to be character searches. What these happen to be is that this one here just is find the substring within this string. So find this particular string somewhere in there. In this case here, we're looking for the word for. And as you might remember from our earlier searches that we were doing using C-style strings rather than C++-style strings, you'll note that it returns the index that is valid for that string. And in case it can't find it, we'll get into what this is in a second because that's what you get back if you can't find it. Then you can also search basically within a substring. And you can imagine how basically it ends up grabbing a certain substring, such as by doing this, and then ends up basically doing find on that substring. Except the important thing to note with this one is that even if you start at element 10, it doesn't find it relative to this position here. It finds it relative to the start of Gettysburg. So it basically would start at 0 here. So even if we do find something within this substring that we're searching for here, starting at 10, which is around this space here and going over. So if I had, say, and in there, it would not return 1, even though within that substring, it's the first one. It would end up adding that on to the earlier count that we already had to begin with. That's an important thing to remember, is that it does not take into account this offset. So then you can also, similar to what I was saying before, with this style substring, you can do the same thing down here, where you go, okay, go 10 characters over, then do the next 10 characters. And then, of course, you can do the same thing with, and one of the things you'll note here is that I'm using CString, and we'll get into exactly what this method does in the future, but you can do it for these style strings, you can do it for C style strings, you can do it for characters, for a lot of these different things I'm supplying. For some of them, you can't necessarily do it, such as for this character here. I can't then give it this one here. You'll see how it gives us this error because it can't find that specific version. It'll give us this error saying invalid candidates are, or invalid arguments candidates are, blah, blah, blah. And really all you had to do in case you wanted to do a character like that is you just convert it into a C-style string and use the quotation marks around it. So effectively then it's a character pointer, even though it only has a single character in there. So that's how you end up using it to get this substring. That does not exist for just characters, and as you'll see up here, it does not exist for C++ style strings either. So in this case here, I'm trying to find this C++ style string 4, and I'm trying to find it within this substring, but I can't do that. As a result, I have to come on down here and use .cstring. And what that does, and this is very important about it, is it converts it within here into a const pointer, basically a const character pointer. This is a template right here, so it could be, in case we went to wchars, it would be a wchar. In case you had your own custom character class or the like, it would end up being that custom character class, and so on and so forth. The major thing about it is it has these two different const protections here. And this one here is just saying that it's not going to modify anything within, in this case here, for doing for.cstring. It wouldn't complain about modifying it in there. And the other important thing is that it's not going to modify, well, you can't modify what you get back. That pointer you get back cannot be used to modify any of the elements within that C-style string. So if I then do this, and this is to help demonstrate it, you're not going to see any errors here, but upon build, you can see can assign to a variable that is const. So that happens to be an important aspect to consider when you ever use CString, and the main reason why CString exists and the main reason why you'll end up using it is so as that you can end up using C++ style strings in C functions that already exist. And these are similar to the ones we've already gone over, and a lot of them frankly are redundant with things that already exist as methods for C++ strings, such as find, such as replace, inserting, etc., etc. But occasionally you'll run into situations where something expects a C-style string, especially a lot of older code that was originally designed to deal with character pointers that may not have been updated, so people just pass in this .cstr. It is really useful, so it allows us to do things such as this whole little C-string searching here where we end up getting the substring like we do up here. Then, similar to find, and you can see down through here, really the next important thing we need to look at is this number here. I said I'd put it off, but now is a good enough time to take a look at. And you can see up here, and really these are the two lines where this is being generated for these two here. And that's how we're trying to find this string 4, starting at element 10. So we're trying to find it basically from here through here. And obviously we're not going to find it. So what we then have to do is it has to have some way of returning it. And since it ends up returning a position, what it really needs to do is it needs to have some constant position they can use. And what it has is this npos. And basically this represents the end of the string. It's a bit more complicated in case we actually take a look at how it's implemented, but that's a good enough view of it in that it is the last index you can possibly have, or it is larger than any string can be. It's basically guaranteed to be the end of your string's size. So you could never have a larger element number than this, and that makes a fair amount of sense with how large this is. So that's what returns on a failure. It doesn't throw an exception, it doesn't do anything else like that. It might complain in case you tried to take a larger substring than what you could, but it might also just end up returning npos saying, hey, we can't find it. So if I gave this thing here something like 999 for it, and then we run this, you'll see that up in here, it ends up returning npos, doesn't crash, doesn't throw any errors for us that we might otherwise encounter. So that happens to be reasonably important to remember, is that it's not going to give us an error or an exception on find or on substring. Well, it may complain on substring. So if I did something like 999 or even just 99 up here, and then run this, You can see how it actually crashes our program. So that is an important thing to be aware of on substrings, even though it actually does work correctly for, in this case here, getting a substring on a search. So that is a valuable thing to consider, and overall pretty important to note the distinction between those two. You can also then search from the back of a string, and there's really only one key oddity that differentiates this from a find, because you might think, okay, that's relatively easy, I just go in the opposite direction as opposed to from the beginning. And for the most part, that's the case. But it has to deal with these indices here. And that's that these indices are measured from the beginning. So if I do, say, 15 over, it's going to basically go, okay, I get this amount, or approximately that amount. And then, if I do, and this is what you'll note down here with these 15 and 5, if I then end up doing this 15 and 5 here, it's going to end up giving me out npos. And the reason for that is that even though what you might think is, okay, I go 15 over, it's around here, and then it goes back 5, but it doesn't go backwards. It does it similar to a substring, so we wind up with these 5 characters, and it goes, can't find any spaces in there, return npos. So it's important to remember that your substrings, whenever you do this, regardless of whether you're searching forward or backward, always go from the beginning to the end. They never go right to left, they always go left to right. That's the case for those. Find first of, find last of. Those you can pretty much guess similar to before, where it's going to try to find the first character in this set of characters. So, in space with the capital, that the first one that's going to end up finding is the C here. Then, in case we search the other direction, though, it's going to start going, okay, from over here, and we find this A. And you can imagine then that we can have basically the same overloads of these finds that we had up in here and for find here, and we do. All of those exist. There's a whole bunch of different ways for searching. But once again, these are fairly simple, just as find something in this collection of characters. It's not finding the exact string, it's finding any character in that string, or in that set of characters. Same thing for find first not of, and find last not of, basically just doing the same thing as find and reverse find, just going, okay, is this character in this, is this character not in this? And that's really all that you need to know about searching in strings, and really that's all that you need to know about strings in general. If you've watched the past 5-ish episodes, I think you'll have a good view of how C++ strings work, how they're put together, and the different things you can do with that. In the next episode, we're going to get into iterators, which are things you can use for some of the stuff such as loops in particular is one of the major common things for them. However, there are also things in terms of some of these comparisons and the like that you can end up actually using iterators for, as opposed to specific numbers, as opposed to going, okay, I want to access this specific element in it, or anything else like that. We'll get into that in the next episode. Thank you very much for watching. Have a wonderful day.